Okay, we're going to discuss questions for discussion, Schiller chapter 6, pages 137 through 138. The first question is asking you to define or describe some industries that you regard as being highly competitive. Examples could be farmers market, could be small family farms, or independent software developers. In a case of farmers market and small family farms, of course, barriers to enter are very small, and in terms of, and the products are typically identical unless you have a specialized organic farm and so forth. When it comes to individual software developers, the product differentiation is very important, but you can imagine that people with some computer skills can enter. There is no need for licensing and any kind of regulations as to what they develop and so forth. Question number 3. If there were more bookstores around your campus, would textbooks prices rise or fall? Typically, more suppliers will lead to lower prices. Okay. However, this is one of those things that you can't have infinite number of suppliers in a small market for a host of reasons, because if it did, then the price is depressed so low that it will not cover the cost of brick and mortar store or the employees and cost of books that has to be stocked. So therefore there's a limit as to how many players can be in the market for bookstore, college bookstore. So that's as far as the supply is concerned, and also they have to be just sufficient number that even through competition they can still make some profit and survive, and so maybe one or two is the max that can support a college campus for that reason. As I said, you can't have too many bookstores because then it would not be sustainable. Even if they all sell at the same price, the fact that all of them will sell only a few units per, let's say, per day or per week, that makes them unsustainable. So they have to sell. Just similar to the discussion we had about natural monopolies. You can't have so much infrastructure to only support a limited number of clients. So therefore, maybe a maximum of 2 or 3 will reach that point. Now, question number 4: why doesn't Coke lose all its customers when it raises its price? Well, Coke has managed to distinguish itself by taste and other attributes, which means that there are some die-hard Coke consumers, so therefore Coke is not an item that would be identical as it compares to other soft drinks. So therefore it has a relatively price sensitive demand curve, but is not flat, so it's a downward sloping. So Coke in effect can set its price like $50 a bottle, and they may sell only a few hundred bottles a year for die-hard Coke drinkers, but they have a downward sloping demand curve, as opposed to, let's say, generic soft drinks, where the consumer considers all of them, these are like store brands, as identical or very close substitutes, and therefore the demand is perfectly horizontal. So that's why Coke will manage to have some customers even if it raises prices relative to its competitors. And finally, question number 8: what rate of output is appropriate for a non-profit corporations such as university or hospital? Okay, so for profit maximizing firm, the production or units of production will be at a point where the gap between revenue and cost is maximized, and you can determine that rate of output for profit maximization by establishing where marginal revenue is equal to marginal cost criteria. At that point, these two curves slopes are parallel, like a railroad track. Any point before and after, the slopes are not parallel, and therefore they will gravitate towards some kind of an intersection. So therefore, that's the rate of output for profit maximization. However, if you're non-profit, then you're not bound by this criteria. You can continue producing this direction as long as revenue exceeds cost. Even though marginal revenue, meaning additional revenue for additional units sold, is getting smaller while the cost is getting larger, and therefore is eating into your profitability, but it's still profitable. And so therefore they continue up to a point where total revenue is equal to total cost, as opposed to marginal revenue equal to marginal cost criteria. And that discussion wraps up our assignments for discussion questions. Next is the problems. The number one, here it asks you to look at the figure 6.5, I believe, and you can, that is on page 125. I have it here, and the question is, what would be the rate of output? Again, the marginal cost curve here is also the supply curve, meaning additional cost for producing one more unit, and that is essentially the cost structure and supply curve. So at the price of 9, a typical firm will trace it to the cost structure, supply curve, and it says I'll produce 3 baskets of fish. At price 13, the production is increased to 4 baskets, and at price 17 is 5 baskets. So that's the output there. Then the question asks how much total revenue is collected. Well, total revenue is price times quantity. So 9 times 3 and 13 times 4 and 17 times 5 will give you the total revenue figures. Now for the total cost is defined as output times average total cost. Now you say, how do I get that? Well, average total cost per unit, is when you take the total cost divided by the total output, and that gives you cost per unit. So I can use this relationship to, if I have average total, if I have a total, I'm sorry, I think it gives you, we have the output at different levels, and we can calculate the total cost, and okay, the total cost is provided on column 4 of page 125, and so that's I didn't even need to really calculate the total cost. It is provided on column 4, so therefore you have that value, and so at 3 units the total cost is defined as, is shown as 31 units. At 4 baskets it is 44 is the total cost, and at 5 is 61. So therefore, if you subtract these two numbers, you get the profit for each level of output. Now question number 4, I know I asked you to do question number 6, but let's not do that. That's a little bit lengthy process here. Let's only focus on question number 4, and I have kind of put together, put together a spreadsheet that captures that. I have output at 10, 11, and so forth all the way to 19, Then total cost is provided also, 5052, that date is available. Marginal cost is defined as marginal cost is defined as change in total cost when you change output by 1 unit. So here I'm subtracting 52 from 50, and that's 2, and then this process continues, and 56 from 52, and is 4 units. So these are all marginal costs associated with different production. Now at price $16 per unit, total revenue is price times quantity, so 16 times 10 and 16 times 11 and so forth and so on, and these are total revenue. Now actually, if you can calculate marginal revenue, which is change in total revenue when you produce one more unit, you get $16 across, and that's exactly the price, because for a competitive firm, the demand curve is also marginal revenue curve, because at $16 a firm can produce as many as they want, and additional sales is always $16. So that's why if you use the numbers and calculate, you end up with the $16. You didn't need to, because the price is the marginal revenue value as well. So therefore in that regard, you have to look and see where marginal revenue is equal to marginal cost. When the firm is producing 18 units, marginal revenue is 16, marginal cost is 16, and therefore that's the profit maximization level of output. At that point, total revenue is 288, total cost is 122, and if you subtract, the firm is earning $166 in profit. Should the price drop to 12, total revenue, price times quantity, is provided on this column, and once again at output 16, marginal cost is equal to marginal revenue. So therefore total cost total revenue, I'm sorry, is 192, total cost is 92. If you subtract that, the profit at that level of production would be 100. So I think that will wrap up the conversation on the answers to the questions. Thank you.